Good evening, and thank you for joining us. I am Corey Gordy, member of the Alaska Common Ground Board, and I want to welcome you to tonight's discussion on Waste to Energy Unleashed. We're happy to have folks from around the state join us for this discussion. We start tonight by recognizing that I and many of the participants in tonight's discussion are in the Anchorage area, and that we are therefore on the traditional lands of the Dena'ina Athabascan people. We honor with gratitude the land itself and the Dena'ina people, past, present, and future. Tonight's event is hosted by Alaska Common Ground, whose mission is an engaged Alaskan democracy. Founded by Alaskans passionate about fostering civil dialogue around public policy issues, we have hosted presentations and discussions like tonight's for over 3 decades in order to build a better understanding of issues important to our state. You can find more information on all our previous events, including several on energy and climate topics, on our website at akcommonground.org. Alaska Common Ground could not do the work we do without the support of our wonderful members and donors. If you would like to support free events like this, please consider becoming a member or making a donation online at akcommonground.org. There should be a link in the chat, and we would love to have you join us. Tonight's event is a Zoom webinar. Mark will talk for about 30 minutes, after which he will respond to your questions. The event will run until 8 p.m. If you do have questions, please type them into the Q&A feature at the bottom of your screen. We will collect these and I'll present them to Mark after his presentation. Please use the Q&A and not the chat. This event is being recorded. It will be available on Alaska Common Ground's website at akcommonground.org. Anyone who signed up for tonight's event will receive an email with a link to the recording, along with other resources on tonight's topic. We've held several events on climate and energy programs, including a series a few years ago on the Anchorage's Climate Action Plan, now known as the Energy Security and Resilience Plan. More recently, we hosted an event on what's happening with recycling in Anchorage, and again, you can find all of these on our website. Tonight, we are going to hear from Mark Spafford, who will talk to us about what's happening with the Muni's Waste to Energy project. Mark Spafford is the Deputy Municipal Manager and Anchorage Hydropower Utility Director. He holds Bachelor and Master of Science degrees in Environmental Engineering from the University of Central Florida and is a registered professional civil engineer with over 26 years of private and public agency experience. Mark was born in Florida, grew up and lives in Alaska, has 2 boys, a girlfriend, and a doodle, all of whom he enjoys spending time with. This is in addition to playing guitar, singing, and making music with his band Staff Daddy across the state of Alaska and the United States. Now I'd like to turn it over to Mark, our presenter for tonight's discussion. All yours, Mark.
All right. Thank you, Kari. Baseball season just started today, and I'm a huge baseball fan. And so my favorite team is the New York Yankees. And so I always say I'm an Alaskan who's originally from Florida, who really wishes he was from New York City. But yeah, thank you for that. I'm happy to be here, and I guess I'll just jump right into it. Share my screen. And you all can see that? Okay, perfect. So without talking about my background or anything like that anymore, I mean, I did work quite a bit in rural Alaska at the Alaska Native Tribal Health Consortium and the Denali Commission during a couple of different tenures there. And so I've got a good background on utilities from, rural Alaska all the way to my, 9+ years that I've spent here at the municipality in a variety of roles over a couple of different stints as, started off in 2013 as the Anchorage Water and Wastewater Utility Operations Maintenance Division Director, then moved over to Solid Waste Services and was the general manager there for a while. And then recently came back in November of last year with the LaFrance administration as the Deputy Municipal Manager and the Anchorage Hydropower Utility Director. But what I'm going to talk about today are just some observations based off my diverse experience here in the state of Alaska with utilities ranging from water, wastewater, to healthcare facilities, to solid waste and recycling, obviously, to hazardous waste and contaminated soil disposal and treatment, as well as, more recently working in the energy and power sector, as the Anchorage Hydropower utility director, and did a little bit of that, kind of moonlighted in some of the energy efficiency and sustainability activities while I was the general manager at Solid Waste Services. But the state, and specifically the Municipality of Anchorage, have a lot of different utility issues that face us right now, as well as the state of Alaska. As I'm sure if you're watching the news, you're probably pretty aware of the natural gas shortage, the some of the issues that we're having with deploying renewable power generation across the state. Wastewater sludge disposal is a big issue here at the Municipality of Anchorage. If people don't know this, but at the wastewater treatment facility, there's actually an incinerator that's at the Asplin treatment facility that basically dewaters sludge. And they have Anchorage Water and Wastewater has a looming capital issue with trying to replace that incinerator because it's on its last legs. It's obviously very energy intensive with natural gas usage as well as water usage. So that poses an issue for the Municipality of Anchorage. There's, of course, near and dear to my heart is the landfill capacity and solid waste disposal issues that we have here, because, even at the Anchorage Regional Landfill with the size that it is now, there's over 14 million tons of garbage that have been placed there since, 1987 when it opened. But it's not an infinite, there's not an infinite capacity at the landfill. And frankly, as big as Anchorage is and as much land as we think we have, not all of that land is developable. In fact, a very small portion of it is. And, basically there's no other spot for a landfill except where the landfill is at right now. And so if we were to fill, when the landfill fills and we have no more space here in Anchorage for a landfill, we're going to have to ship out that material. And what's most costly about solid waste disposal in this state, which people don't think about all the time, is the actual transport of it. And so the majority of the employees at the Department of Solid Waste Services basically drive in circles all day, either collecting garbage or collecting recycling and transferring it out to the landfill, or driving leachate back and forth between the disposal location with Anchorage Water Wastewater Utility and the landfill itself. And so, and also there's a big low-level hazardous waste issue with PFAS, PFOA, and other soil contamination across the state. And I say that in the ends of there's not a economically viable or a real economic way to dispose of that material. And so basically that material has to be put on a barge or trucked down to Anchorage, put on a ship that goes back south and then gets transported by rail after it gets off that ship and disposed of at a hazardous waste landfill, in the middle of Utah. And there's also, if you've driven by the Anchorage Regional Landfill, you can tell that there's sometimes odors that are emitted for that. There's, like I referenced to, there's a large amount of leachate, which is liquids that percolate through the garbage mass that we have to collect and have to treat appropriately, that ultimately gets discharged to the Anchorage Water and Wastewater Utilities collection system. So there's a lot of leachate and landfill gas regulatory challenges that are faced at the landfill as well. And so just over the course of the different positions that I've held and looking at the different utility challenges that we have, I think what I'm going to talk about today is we found, the silver bullet is what I like to say for a potential technology and a potential solution that will take care of a lot of those issues that I just discussed, that are problems statewide that affect economic development. They affect regulatory compliance. They affect the cost that we're paying for utilities, whether it's, water, wastewater, or solid waste, or, power, which we're all very keen of right now and very aware of right now, as well as heating, right? So, but that's what I'm going to discuss today is what I think is our, silver bullet solution to, some of these problems that we have here and these issues that we are facing here in the state of Alaska. So just to touch on again, some of my duties, I'm the deputy municipal manager. So I have purview basically over the utilities. So that's the public transit department. I'm also like Kari mentioned, I'm the Anchorage Hydropower utility director. So much to the chagrin of my girlfriend, I can tell her that I am in fact the boss of me. I also get to work with the Anchorage Water and Wastewater Utility, of course, Solid Waste Services, Merrill Field, who actually services a lot of rural Alaska. And not so much the port these days, but the port will have a big influence in the vision for this project because, these are also local issues that we have. So for some of those utility problems that I discussed, but there's also statewide issues that could potentially benefit from being able to ship solid waste and other materials here to Anchorage to be effectively treated at the waste to energy site that we're envisioning. And so I get to like interact with all those great people in those different departments. And then I've been tasked, luckily through the mayor and my direct manager, Becky Wint Pearson, who's the municipal manager, with working on some of these bigger projects like the waste to energy project, the energy security and resiliency plan. I'm also working on the stormwater utility implementation, investigating that, and including some other interesting, hydroelectric watershed issues with the Eklutna watershed, including, looking at how do we get sockeyes back into Eklutna Lake, and, how do we protect the valuable resource that we have for drinking water that not a lot of communities have, that we're lucky to have here in Alaska. So yeah, I get to play in a lot of different fields that are really, really interesting and help keep my curiosity always at a pitch. So it's good stuff. But yeah, so we'll talk about what we're here, what we've looked at, the efficacy of this type of technology around the world and here in the USA, a high level overview of what the technology entails, some of the work that we've done to date on the design and permitting and business planning for the facility, as well as what we're going to do next. And so I like to start here with this one. This is one of the things I'm most proud about, in my previous stint as the general manager at SWS. And I like to reference this because this was a $120 million project that we basically went from planning to design and commits construction in about 3 years. And so I like to use this because what happens sometimes, and I'm sure you hear it all the time, is that, we sit here and we study things to death. And I just want to make sure that everyone knows that we are capable of developing and implementing large projects here in this state without having to wait 20 or 30 years to get them done. And granted, this isn't the central transfer station, again, which I'm really proud of the work that we did there while I was there and the team that we had. But the best thing that you can do is have a good plan and start doing something and getting things done. Because otherwise, if you don't take those calculated risks and you don't make things happen, things just kind of tend to get kicked around and kicked down to like the next administration or make it the next person's issue. And so getting things done in a timely manner and in a smart and efficient way are very, very important to making sure that the plans that you have and the projects that you're envisioning become a reality, and they are possible. The point of this slide with the energy security and resilience plan is I like to mention the fact that what we're going to talk about today, the waste to energy and the silver bullet that we're envisioning here for this project, it's not something that, Mark Spafford just came up with. These were recommendations from a number of different planning documents that were put together by lots of different members of the community, and something that the Anchorage Assembly approved in 2019 to look at, different things around the community that we could do to, improve resilience, improve the environment, improve people's, sustainability and energy efficiency, lower people's bills, and make our community more resilient at the end of the day. And so looking at different ways to utilize, the 1,000 tons per day of garbage that we're disposing of at the Anchorage Regional Landfill, as well as the 14 million tons of garbage that are there, were very important parts of the energy security and resilience plan. It was also a big part of the solid waste master plan, which was the first master plan in over 30 years at the time that we put together in 2017, 2018, was to look at different ways that we could better utilize, this stranded resource, as I like to call it, that's out the landfill, which is basically decaying trash. And this was also a recommendation from the Solid Waste Services strategic plan, because if you think about it, what the Solid Waste Services disposal utility sells is airspace at the landfill. So the more that you can do to conserve that airspace, the better off we're going to be as a community, because that's what we sell as airspace. And it helps us to be more self-reliant. and not dependent on, our neighbors or somebody else to help us, deal with some of our local issues, which if you think about it, a lot of times we're in Alaska, we're left with having to rely on solutions that are outside of the state instead of right here available locally. And that causes a lot of issues like, being more economically resilient, shipping more money out of state instead of trying to keep as much of that money to better bolster the economy here in Anchorage, and as well as Alaska in general. But this was also a big recommendation from the SWS strategic plan. And I don't have the animations on this unless I can try to get this to work. But basically what we have is, this should be a countdown, basically, is what we're seeing here. But it's a finite quantity. And the sooner that we can plan and account for capacity at the landfill, the better. Because I don't know about any of you, but the sooner that we start planning, the sooner we can figure out what we need to do as a community, because we might have 40, 50 years left of landfill life at this point, but that's going to be here before you know it. And so the more that we can do to plan for capacity and take care of that valuable resource that we have here in Anchorage, the better. So basically, once we got done with the transfer station and got that going in 2019, I talked to my boss at the time and said, hey, what should we start looking at next? And through discussions with the administration at the time, that was during the Berkowitz administration, it was like, let's look at waste to energy and start putting a lot of work into that. And so that journey kind of started in 2019 and ended up right before COVID occurred, unfortunately, in April of 2020. But it basically resulted in two different reports. And so one was, what are different ways that we can look at waste to energy? What's like the suite of technologies out there, and what makes the most sense here in Anchorage based on our goal of extending the life of the landfill as long as we possibly can. And so that was the first paper, the white paper report, that said basically, hey, let's look at waste to energy thermomechanical treatment to generate power. And that led to basically a feasibility study, which is essentially a preliminary engineering report, which said that if you want to implement this type of waste to energy technology, here are the different steps that you're going to have to do. And so just to look at kind of like a high level overview of the different waste to energy technologies that were evaluated, thermochemical being, one's incineration, gasification, pyrolysis, and the other one being some of those biochemical processes like that you might have heard of, like fermentation and anaerobic digestion. The key thing to remember here is a lot of these technologies aren't tried and true with respect to treating municipal solid waste. Like, for instance, I'm not trying to be not saying that gasification or pyrolysis wouldn't work, but some of those technologies are very dependent on having a constant stream of the same type of material, whereas gasification is a good process for, like, if you were just treating biosolids from a wastewater process. But when you have a bunch of different things that are being thrown away, like in your typical roll cart or garbage can at your house, it's hard to get a consistent stream of the same type of material to be able to treat that. Pyrolysis was something that was great, but it wasn't something that was readily commercially available. This was something that was stuck on like a, professor's bench scale thing, treating a pound of garbage a day, at Penn State. Fermentation, a different process, that resulted in ethanol, which is not really a big market here for ethanol. And of course, anaerobic digestion with wastewater sludge, or just throwing the garbage in a big reactors. That's something that is tried in a few different locations in the lower 48 and around the world. But again, we're living in Alaska. Anaerobic digestion is a high temperature process. And so we stuck on incineration with the production of electricity just because of the robustness and how long it's been around. And basically, with that type of process, you can throw everything into a pile. You don't really have to have source separation, and it's going to work. And they've been doing that type of process for a very, very long time around the world, and very successfully for that matter. So to that end, here's kind of a list of the different entities around the world or countries, and kind of the prevalence of the different waste to energy facilities that are here. As you can see, the United States has 66. There's thousands of these facilities located all over the world, with the prevalence of those being China's been a big adopter of the technology here recently because of their industrial boom. Japan has quite a few of these facilities, which I've seen those firsthand through my travels. And they're space limited, right? Like they have a lot of people that live there and not a lot of developable space. So they need to do whatever they can to reduce the amount of garbage that they have to landfill, of which a process like waste to energy will reduce the volume that you have to dispose of by, over 90% in some cases. And of course, Europe too, just because of their, embracing of renewable technologies, and they have some of the same space constraints as like, Japan, whereas they don't have a lot of space, don't have a lot of space for landfilling. And so they've decided to, make the best of that resource instead of letting it just rot in a landfill forever. And again, in the United States, New York and Florida, back to my connections between those two states are kind of like the meccas, so to speak, of waste to energy technologies, with Minnesota kind of being a close third for both of those. But today there's approximately 66 waste to energy plants in the United States, and they treat about 13% of the solid waste that's currently being generated in the United States, with about the other 52 to 53% of that being landfill traditionally, and the rest of that being diverted through different recycling programs and stuff like that. Facilities that are close to us, there's one in Vancouver. I like to use the one in Honolulu because they're basically on an island as well and are space constrained, similar to like we are. And Honolulu actually treats wastewater sludge, which is something that we're proposing here in Anchorage to do as well. One thing that does happen is we've had sometimes when I talk about this, it gets confused with our existing waste to energy process that we have at the Anchorage Regional Landfill, which it's a landfill gas to energy process. So what we do as part of our regulatory compliance is we have to collect and destroy the methane or landfill gases that are being generated, of which the majority of that is methane. And so we have to flare that. And what we do right now is, since about 2013, is we've partnered with Doyon Utilities. They have a 7.2 megawatt facility that uses about half the gas that we're collecting right now to produce power for the Fort Richardson side of the Jayberry installation. But what I want to point out is that it's great that we have that resource, and it's been the revenue that we've collected off that in the last 13, 14 years helps to subsidize our operations. It helps keep our rates lower than they normally would be. But the type of waste to energy plant that we're envisioning here is about 2.5 times more efficient than the landfill gas to energy plant here, just because of the type of process it is. So we probably get about 10% of the energy content out of the existing garbage, whereas if we were to treat it in the type of waste to energy process we're going to talk about here, we'd get 2.5 times more of the energy recovered from that same material, as well as reducing the volume by over 90% of the garbage that's going into the landfill, which results in extending the life of the landfill by over 100 years. And so basically with this, you would solve, the landfill issue for the next basically 150 years, and for my kids' generation, they wouldn't have to worry about that, which is something that's very appealing. Again, some of the advantages of waste energy plants, which I've kind of rattled off here a little bit, is it's commercially proven. People have been doing this technology, even here in the United States for a long, long time. And it's a renewable power, as defined by the Department of Energy. And the great thing about this type of power is it has a 90% capacity factor, which that means it's basically, if it's a well-run facility and operated, it'll be there 90% of the time. And what's appealing to that, if you're an energy and power provider, is that you want to make sure that when you're dispatching energy, that you can rely on the power plant, the garbage power plant, that's going to be, generating 25 to 30 megawatts of power every day of the week. And that's been some of the struggles, in my opinion, of some of the power generating entities here, is how to integrate some of the other more intermittent renewables like solar and wind. Whereas, they have their own benefits, but one of the cons of those is like the energy storage and, not being available exactly when the power company and the power demands require it, just because of grid demands. Not to say you can't do it without batteries, but the waste to energy plant would function basically just like one of their natural gas fired plants, and it could be easily integrated into the grid system that we have right now. And like I said, it's a mature technology. It's been around. Like I referenced on the last slide, it's got a high gross energy output, especially relative to like burning landfill gas to create power. There's vendors all across the world that do this. I mean, like I said, there's 2,000, 3,000 of these facilities around the world. So it's, it's a mature technology. There's not so much risk in the actual operations and maintenance of them as maybe some of those other processes that I mentioned earlier when we were doing the feasibility study that we looked at. And again, one of the things that I struggled with when I was the general manager at SWS was trying to get people to recycle more, right? Because in the waste disposal hierarchy, if you can recycle it and repurpose it, that's the best use for it. But however, trying to get people to do the right thing, we're isolated here in Alaska. We don't have, really any markets, so to speak of, on a large scale to be able to divert that material that we're currently, collecting from our recycling programs. And essentially the majority of that material has to be put on a barge, shipped south, and, processed at mills outside of Alaska. So it's not really doing anything other than keeping material out of the landfill, to get as much of the economic benefit as we could potentially realize if we had a, robust and bigger recycling program here. But with I always considered this type of process the ultimate recycling program, because it's like the closest way to get to that circular economy where we're, utilizing as much of the material as we can rather than just sticking it in the landfill to rot forever. Another big thing that landfills struggle with, again, like I had mentioned earlier in my presentation, is dealing with leachate and landfill gas production. We probably have 3 or 4 people that, they drive leachate in circles all day long, taking it from the landfill to dispose of it in the Anchorage water and wastewater utility system. And so if we could do anything to reduce the amount of leachate that we're generating, that's a good thing, which this process would do, because we're able to manage the landfill in a much different manner to minimize the amount of rainwater and leachate that's being produced. And of course, if you're burning and thermally treating the garbage that's going into the process, you basically destroy the organics. And so you reduce to zero the amount of landfill gas that you're being produced. And of course, another good advantage of this plant, especially given the situation that we're here in Alaska with natural gas right now, is that it's going to offset that natural gas usage and allow it to be used for heat or for energy power production someplace else. And like I mentioned, it's a renewable energy source. Very cartoonishly, this is pretty much what the process is waste just goes into like a transfer station, gets stored in a pit. There's a big crane that basically I like to call the claw that throws it into a boiler. The boiler is obviously like at between 1,500 and 1,800 degrees. It heats up, the trash gets burned. It causes heat. The heat uses steam, creates steam from water that's there. The steam goes to a turbine, it generates electricity, and electricity goes off to the grid. And obviously what's coming off of like the flue gas is treated in very high tech, very expensive scrubbers and bag houses, as well as potentially some other, depending on like what your permit requirements are, air pollution control equipment. And ultimately all the fly ash that's collected from the bag houses and the bottom ash that comes off of the boilers is taken to the landfill for disposal. And that's where you get that 90% volume reduction versus what's going in. Another piece that we're envisioning for this is soil treatment, and PFAS, PFOA, and other contaminated soils across the state. There's some smaller scale methods that are available here in the state to treat that material. But for a large portion of it, in order to treat that environmental liability, it has to get taken out of state for disposal at a cost that's excessive, as well as it takes that money from the economy of Alaska and puts it somewhere in Utah or wherever that material ends up. So what we're proposing here is to use a portion of the power that's being generated to treat contaminated soils from across the state to address that environmental liability, as well as keep that revenue in Alaska, help keep that money here, help to pay off the debt that's associated with the facility, as well as be able to take care of ourselves. So big picture benefits for waste to energy here in Anchorage is, again, like I said, it's a renewable energy. It'll generate between 25 and 30 megawatts of power on a regular basis. Another big thing is we're looking at how to utilize any of the waste heat that we could collect. Now, I should say, if we had, depending on where it goes, if there was a large scale industrial customer for the heat that was being produced, that would be a way more efficient, way more cost effective use of the heat rather than producing steam to turn a turbine that will generate power. But unfortunately, we just haven't been able to identify large industrial off-takers, but there's still a portion of the waste heat that's going to be generated from the facility that we could potentially use and generate revenue as well. And also there's ash recycling. So what we're able to do as part of the process is recover precious metals that are coming off of the bottom ash that aren't necessarily being burned up or treated in that manner. And also, like I said, this project started, before it became a power producing project, was to extend the life of the landfill over 100 years. And from like a greenhouse gas emissions life cycle analysis, treating solid waste in this manner versus traditional landfilling reduces greenhouse gas emissions significantly, because you're dealing with, you're still dealing with carbon dioxide, but you're not dealing with methane that's being released from the landfill, which is, depending on the literature that you read, is 27 to 28, even greater than that, more powerful of a greenhouse gas emitter than CO2. And again, like I said, another big benefit is going to be the contaminated soils and biosolids treatment components of it. Again, the capacity factor, availability is a capability, which is something that I've started saying. Having it reliable is something that makes it easily integratable into the power distribution grid. And then, we could even do things down the road if we decided that, we don't have a low level solid hazardous waste landfill disposal capability in the state, but we could potentially solve that issue if we're able to free up other space at the landfill to dedicate the other activities and not just disposing of ash. And so that's kind of like some options that I give that could be for future revenue generating purposes to pay for the city, or to pay for the facility itself, to pay for the operations, as well as, again, to help spur on economic development, keep more money here in the state of Alaska and the Municipality of Anchorage. So this isn't easy. A lot of this before, the Anchorage Assembly and the administration saw fit to, give us the first batch of funding in the form of $8 million from capital funding from Solid Waste Services and Anchorage Water and Wastewater Utility to start looking at this, really had no idea about all of the different buckets and all of the different little activities that are associated with trying to develop a power production, solid waste, soil, contaminated soil treatment, waste heat, you name it, treatment process. But there is a lot that goes into it, and it's not easy, and there's a lot of moving parts. And so this slide like makes my head hurt because of all like the words and all the different boxes, but it's just to kind of drive home the point that it's an extremely complicated, lots of moving parts process to develop a project of this size and this magnitude. And so, again, some of the completed activities to date since, we started this in 2019 was we've created or completed the feasibility studies, preliminary engineering reports. We've got that initial investment of funds from the administration and Anchorage Assembly in the form of $8 million. We've stood up the program management office, which was that previous slide, and all those different boxes about all the different things that we need to do. We've got pretty much the majority of the RFPs have been issued to look at, what are the different potential waste sheds, right? Like I envision this as like, if other entities and our other peer solid waste utilities want to get out of the garbage business, they could potentially ship their waste to us. Even entities like Juneau, who have, landfill capacity issues as well as disposal of biosolids issue, potentially if it's economic enough for them, could ship their waste north to us instead of having it go south, like they're considering right now. But we're looking at that. We're looking at waste characterization, which is basically like the fuel study. What's the energy content of the solid waste that we have? Looking at starting the permitting from baseline air monitoring. We're, of course, doing site selection. We've got our public relations and communications, because obviously educating the public about a project like this is always important in any kind of public works project, but it's going to be especially important just because of the magnitude and perception about projects like this. And of course, we've prepared the scope, schedule, budget, working on that now. And also the biggest thing that we're trying to do right now is figuring out how to pay for it. Now, the estimated cost for this project as envisioned is going to be north of $700 million. That's just our very preliminary cost estimates. So we have to figure out how do we pay for that, which is going to be on the back of the revenue that's being generated that we're proposing for the facility, as well as hopefully minimizing the rate increases that would be associated with it, from landfill disposal fees. And the last little bit that we're working on right now is 3 different RFPs to bring on a design engineer, the ultimate operator of the facility, as well as a construction manager who would build a facility so we can bring together that design, or the owner, design, operator, and construction management team to go, okay, well, how do we do this in the most cost-effective way and get it done right the first time, so you don't have people that are just used to garbage trying to design a power plant. And so that's what we're working on right now, and those RFPs are forthcoming. But this is some potential site plans that we're looking at, and these are not saying that where that facility is going to go at the end of the day. This was just to give people an idea, if it was to go out at the landfill, this is what the potential facility would look like on the existing footprint that we're looking at potentially siting the facility, out at the Anchorage Regional Landfill. Another one could potentially be at the Central Transfer Station site. And so again, this is just another conceptual layout of, a couple of different sites that we're looking at right now, which we're right in the middle of a site selection process. So more coming on that as well. Like I said about the Central Transfer Station, typical waste to energy project timelines are 10 years, and we're trying to condense this to as short a time frame as possible. And so optimistically speaking, we're hoping to get the design and permitting done over the next 2 years. And, best case scenario, having, once we get the business plan done, and assuming that, the administration and Anchorage Assembly is in favor of the business plan and the costs that are associated with it and the revenues that we're going to make and then the impacts to some of our ratepayers here in the community, getting something stood up and in operation by, 2030, 2031. So very aggressive schedule, but you got to be aggressive on stuff like this, because that's the only way to truly get things done in a timely manner. We're also setting up dashboards just because of the size and the scope and the magnitude of the project. And we want to make sure that we're being as transparent as possible and letting people know about how the funding is being spent, the jobs that are being created as part of this project, the economic impact to the community, and all the other project management and engineering metrics that, we like to see with developing big projects like this. So what I like to show about this project or with this slide is that, we've got a lot of things that are kind of in the hopper right now. We're looking at getting excess land if we were to site the facility at the Anchorage Regional Landfill, from J-Bear, because there's adjacent land there that J-Bear is currently sitting on that we could potentially use for it. We're in the process of lobbying the federal or congressional delegation for looking at investment tax credits and other forms of grants that are out there to potentially pay for that large capital cost that's associated with it. A big thing that we're working on right now is developing the business plan, which will that's what we would use to take it to shop for the entity that we would get to borrow the money that we would get to borrow for it to construct it. And so that's a big piece of the design and permitting right now that we're working on. And what I like to show with the pictures is that, my girlfriend is, she travels around the world for her job, and she's shown and taken me around some cool places that I'd never seen in my life. And I like to take her to garbage burning plants and some of the more exotic locations that we go to. So on the left there is Tokyo, and I was there last year. And, Tokyo itself probably has, 20 plus different waste to energy facilities that are within the city limits itself, right in the middle of the community, right? there. It was next to a library. It was next to commercial. It was next to private housing. And the picture on the right is, when we were in France late last year, in Lyon, France, there was a facility in the middle of the city, right next to the university, right next to, again, other private and commercial entities, residences. And so just to show that it can be integrated into a community, they're not, your grandpa's burning, garbage in a 55-gallon drum in the backyard. It's a state-of-the-art facility that takes into account, operating requirements from your permit and the environmental controls that are associated with it, because that's how important it is to make sure that what's being emitted from the facility is clean and it's operating as well as possible, and that it is something that you can integrate into the community and it's not impossible. Anyway, that's it for the presentation. And I think I've talked a little bit longer than I was supposed to, but maybe now we can just go to asking questions.
No, that's awesome. Thank you so much for that interesting presentation. Just a reminder to everybody, we've received some questions, but if you have any questions for Mark, put them in the Q&A at the bottom of your screen. I wanted to start with prior to we gave people the option of sending in a question ahead of time, and then we also got one of the questions during your presentation. So a lot of concern about the emissions and the pollution and the hazardous waste and all the toxic emissions and how that's controlled, and how do you approach all that?
Yeah, so about half of the capital cost that's associated with this facility. So if you say $700 million, about half of that is going to be on the back end. And when I say the back end, that's the air pollution control equipment that's associated with it. So you've got, scrubbers, you've got bag houses, you've got afterburners that are all there to treat any kind of the particulates that are coming out of, like, the gaseous, it's called fly ash, right? That's coming out of that's not going to the bottom ash of the facility. And, it's probably going to cost us, $30 million to $40 million a year to operate that facility. And about half of that is put into the operations and maintenance on the air pollution control equipment. And if you don't meet your permit requirements at the end of the day, you have to shut the facility down. And again, back to my availability as capability, if you're not operating your facility, you're not making money and you're not doing what the intent of that was. So it's very important to meet your emissions requirements. And there's a lot of time and effort that's spent in reducing the emissions that are coming from those facilities. And so that's why I like to show those pictures of those facilities being located in the middle of large cities around the world, is that it's not impossible. If you operate it correctly and you design it and build it correctly, it can operate in an environmentally sound manner that, there's no proven health effects, whether or not anybody wants to believe it or not, that are associated with a well-operated and well-maintained waste to energy facility like we're envisioning here in Anchorage. And it'll be designed to meet the best available control technologies, when we get to that point of the design of the air pollution control equipment.
And there's a specific concern about, and you discussed PFAS contamination. Is there anything that you would manage differently because of that? I mean, because that's obviously those are.
That's the beauty of the process, right? So, there's information from vendors around the world that do this type of process that have shown that due to the temperature, the time that the garbage spends in the process itself, and the amount of turbulence, the amount, like just dumping the garbage in and having it roll down a grate in a boiler, those are all things that lead it to being able to break down those PFAS bonds to hydrogen and fluorine, or basically their elemental forms, and basically breaks that PFAS and PFOA down. So that's kind of the benefit of this type of process, is because it'll treat the solids that are coming in, just because of the heat and the residence time that's associated with this type of process. So it gets a high level of reduction of PFAS and PFOA from any kind of emissions.
So there's the air emissions, and then there's the ash, and the ash has to be disposed of. And so there's concerns about that aspect of it too. Is there anything you want to add about that particular concern?
Yeah, so the ash again, I mean that's where you get your 90% volume reduction, right? And so that's one of the highlights from a solid waste management perspective, that this, extend the life of the landfill another 100 years. But what happens with that ash is basically the bottom ash, which is coming out of the boiler, and the fly ash, which is being collected from the scrubbers and the bag houses. Basically that gets mixed together and it gets quenched and it gets put into like a stabilized mixture. So it basically solidifies it and keeps like any of those materials that are being collected in the bottom ash and the fly ash from basically leaching out of it and going back into the environment. So it's basically like put into like a very hard, not like concrete, but a very solid form. And then that's what gets placed into the landfill. And you're able to operate the landfill on a much different basis, right? Like you're able to cover it every day so that you don't have all of the, rainwater or snow melt getting into the ash and causing you issues with, having to deal with, any kind of slurries or anything like that would occur. But basically you stabilize the ash, the bottom ash and the fly ash. So that way you're not leaching stuff out into the environment.
All right. On a different topic that a lot of people are wondering about, I think the questions I think are coming at a couple of different things. One is just how much waste would this go through? And so what sort of portion of, let's say, waste that would normally, Anchorage's waste that normally goes to the landfill would be diverted to this. And then there's also how much energy is going to be produced and like terms of households.
Yeah, so that's a great question. So that's the beauty of the process, and that's why that was one of the main reasons why we landed on this type of waste to energy process, was because you could basically throw everything into it. And so that would be the vision, is to throw as much as we, everything that's currently going into the landfill today would be what we'd envision going into like this process. So we don't want to like continue to not only treat like a portion of it, because then you're losing like that, like I was mentioning, like that energy production value that you're going to get out of it. Because whereas if you just let the garbage decay, you get about 10% of the recovery from the energy that's associated with that solid waste versus 25% if you are to thermally treat it like we're talking about with this waste to energy process. But
So
this won't do any. Go
can
ahead.
I
Go ahead.
clarify that? So you're talking the first one you mentioned is the methane capture that already happens.
Correct.
Yeah.
Yeah. And so yeah, and the beauty is like, we wouldn't want to, we're not going to like start throwing away recyclables, which I know, and a lot of people like allude to that, because, that would defeat the whole purpose of having a recycling system. And, like I mentioned during this presentation, that's much higher on the higher on the hierarchy than thermally treating it like we're envisioning here. So yeah, so we would still make sure that we were, keeping the recycling system that we have here in Anchorage stood up. And in fact, I think we need to double down on it, because, this is just a good point that like the more material that we can keep out of this process and find a better use for it, the better. And typically communities that have this type of process usually have higher recycling rates anyway. Because you don't want to have to expand your waste to energy process if you don't have to, because it can be expensive.
Yeah, there was some questions about plastic recycling and also composting, and how all those things should still be happening to try to reduce the waste that we're sending anywhere.
That's correct.
What
Yep.
you just said. There's a very specific question that I assume it would be built to withstand a magnitude earthquake.
Yeah, that's part of the capital cost that's associated with it, right? Because it has to be designed around, the seismic standards that we have here in Anchorage, or have, in this part of, assuming that wherever it gets built. But yeah, that's a large part of the cost associated with it, is for seismic standards.
And did you answer the question about how much power would actually be produced?
We're estimating between 20 and 30 megawatts.
Which is, how many households is that?
That's equivalent to, like, with the capacity factor of 90%, it's about 5% of the total like rail belt demand, which I think is around, that'd be like 1,800 homes. And we're still putting like the finishing touches on those, but yeah, it's about 1,800 homes that it could power on a regular basis. I'm sorry,
And
18,000, not 1,800, 18,000.
you bring up the rail bill, and that brings up people are wondering about materials coming into the facility from other locations. And then obviously there's the potential to sell the energy to other locations. And so that's all part of this project and planning for it as well.
Yeah, and that's one of the considerations, like with the site selection, right? Like if we were to get, if we were to start importing solid waste or, contaminated soils to the facility, it's like, how do we get it there? And so, like, we're on the rail belt, right? So, like, an easy answer is like have place that's close to the rail spur to be able to transport that material, so that you're not having to like drive it or anything like that. So, like, rail spur location, proximity to rail spurs is all part of like the site selection process and goes into like the scoring of it. So yeah, so we're looking at, potentially railing it is probably the easiest, quickest way to get stuff from north and south to Anchorage.
And then I, I guess what limitations are there on terms of what goes into the facility?
Again, it's municipal solid waste. So if it's your typical household municipal solid waste that we're taking out, that we're burying every day at the landfill, it's that same type of material that will go into this process itself. Now, of course, that's why we have like a household hazardous waste, diversion program, right? Because we don't want to burn stuff like that. And so that's what I'm saying. Like we have to double down on materials that were being diverted from, the landfill itself right now, is that we even have to stand up those programs even more robust to make sure that we're not, disposing of materials that we don't necessarily want to treat, because that's going to cause us, more issues on our air pollution control equipment and cause that system to be more expensive, if we just keep it to like the typical municipal solid waste. And like, we don't want to burn tires, right? You can burn a limited number of tires, but because tires burn so hot, you just can't throw like all the tires that you collect from, the spring and winter tire changeovers that we have here in Anchorage. And it's a mountain of tires that we get, and they take up a lot of space in the landfill. So if anybody out there in Zoom land's got some ideas about what to do with a large amount of tires, we are all open to those ideas. And you don't want to like you don't want to throw away stuff in there that's going to like blow up, right? Like, so you don't want to throw away like propane tanks. And the operators of these facilities are very skilled and very adept at looking at what's in the garbage and checking it before they're actually putting it into the boiler itself, because obviously minimizing the wear and tear on your boilers is a big deal, because that's the heart of your process.
And then I think this will probably be our last question. What's the lifespan of this facility expected to be?
Yeah, I mean, that's a great question too. I mean, there's facilities in Florida that were built in the 80s that are still operating, and so 40, 50 years. As long as as long as the facility that's well maintained, and you're taking care of it over time and not just running it into the ground, right? So it's making sure that you've got competent operators, that you're on your capital replacement schedule, and you're taking care of it, and having a well-run facility.
I think that's it. Although we did get people are really interested in what can go into the facility. So there's a lot of questions about that. Oh, and we have a possible solution. Can you possibly use the steam produced to clean the tires and shred them down to use in construction? So there you go. Maybe there's something there for you. You can look at the Q&A. Well, I really want to thank you, Mark, for a great presentation tonight. We know you're busy, and we really appreciate you sharing your insights. And I'm glad you shared your information, and that will go out with the information with a recording of tonight's event, so that people have access to that. And then just a huge thank you to Alaska Common Ground's Climate and Energy Working Group, who put this event together. The work group includes Mary Lou Hall, Cami Dalton, Peg Telston, and Gretchen Nelson, who have put in many hours on these topics. We'll be working on follow-up events, so stay tuned. An additional thank you to Jess Brolick for setting up and running the Zoom show this evening, and the multitude of other things she does to make Alaska Common Ground's efforts possible. And a special thanks to all of you who took the time this evening to attend this session and learn about this exciting new project in Anchorage. And a reminder, we can't host these events without the support of our members or donors. If you are not already an Alaska Common Ground member, we invite you to learn more about our organization and become a member or make a donation at akcommonground.org. Your support fuels our work to advance a more informed and engaged Alaska democracy. Thank you again for joining us, and we hope to see you at a future event. Thanks, everyone.